let's go with Kane. What does A do?
Amplitude.
A is the amplitude. It changes the amplitude. It's a vertical stretcher. B, what does B do? James Musara, what does B do?
B
Changes the period. How do I find the period from B? James?
2 pi over
B. Okay. The period is 2 pi or 360 divided by B to get the period. Cool. What does C do, Devin?
It's the
Horizontal shift. And Sims, what about D? Middle vertical, something like that. Vertical shift or center line. Good deal. Let's review the process that we talked about earlier. So, we got this cosine curve, and in my mind right away, a positive cosine curve should look like that, yeah? Let's start with the factoring. Does it need to be factored, Ms. Trim? Does it need to be factored? It does not need to be factored. It's already factored, so we look, but we didn't need to here. All right, what's the starting point? Ryan, is it 2 pi over 3 or negative 2 pi over 3? Negative 2 pi over 3. Then we go to the period. What is the period, Ms. Lar? Or how do I find the period? Either one. 2 pi divided by 2, so the period is pi. Yay. What is the end of a wave then? If it starts at negative 2 pi over 3, travels pi, where does it end, Triana? Pi over 3, yes indeed. Okay? What about the last thing, quarter waves or little distances? Remember to find the 5 points. We divide a wave into 4 equal parts, so what's each quarter wave? Anybody? Pi over 4. Why do you say pi over 12? I like pi over 12. Why pi over 12? Common denominators. So let's go back to common denominators. The common denominator between the starting point, the ending point, and the quarter waves is pi over 12. So negative 2 pi over 3 becomes how many pi over 12? Negative 8 pi over 12. And what is a quarter wave? Pi over 4, or actually what's the end of the wave then in pi over 12? 4 pi over 12. And what's each quarter wave? 3 pi over 12. Cool. So, would you slap your starting point down? Negative 8 pi over 12. And let's mark the other 4 points we're going to need. Each time we're going to travel how far again? 3 pi over 12. So we're going to go to negative 5 pi over 12, then negative 2 pi over 12, then pi over 12. Maybe I should have put a bunch of pi over 12 tick marks in there. What do you think? Alrighty. 3 pi over 12 more is 4 pi over 12, and that's all good. Cool. Now, let's put in our vertical axis. Where does the vertical axis go? Where? It's between these two. If I split it, wouldn't it be here? It's 0 pi over 12, and then 1 pi over 12. All right. There's my vertical axis. W. Okay, what's my center line? Oh, get myself negative 1. That's optional. I don't care if you put that in. How high do I go? What's the maximum y value? 3. What's the minimum y value? Negative 5. 2, 3, 4, 5. Alrighty. Cool. We're almost there. That quote-unquote starting point, where is it? At the top of the wave, at the middle of a wave, at the bottom of a wave? Top. Why top? Positive cosine starts there. So Where is it at negative 5 pi over 12? Center line or min? Center line. And where is it at negative 2 pi over 12? And negative 5. Where is it at pi over 12? Center line at 4 pi over 12. The top. All right. Make a nice pretty wave that you would put on your fridge. And there we go. Are we cool? All righty. Do you want to try one on your own? Go for it. Shame on that person that said no. Remember, after factoring out a half, if you're not sure, think, well, if I multiply it back, would what I did go back to where it was? So,
I have a question.
yes, hit me.
So, this doesn't make sense.
Okay. Why? That's not really a question. That's a statement. But okay. Go ahead.
Well, if you factor out the 1/2,
Uh-huh.
does the 1/2 do anything after that? Or no?
It changes the period, and it changes the pi over 4 as well. You have to factor out
But
the
you
half.
don't need it after it's factored out.
It changes the period, so yeah, you do.
What is 2 pi over
So the question is, yeah, what's pi over 4 divided by a half? Is it pi over 8 or is it 2 pi over 4? Pi over 8, check your work. If it's pi over 8 and you multiplied it back, would it be pi over 4? It's not pi over 8. Okay, if you put pi over 8 here and distribute to check, would it be pi over 4? No, that's pi over 16. So pi over 8 is a wrong call. It's pi over 8 divided by a half, which means times 2 over 1. So it's 1/2, or pi over 2. That checks. That's pi over 4 when you multiply it together. So make sure after you take a guess that you check. Hopefully your important points, quote unquote, are pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2. Yes? Your starting point is pi over 2 after you factor. Period's 2 pi over a half, which is 4 pi. It starts at pi over 2 and goes 4 pi. It ends at 9 pi over 2. And the quarter wave is 4 pi divided into 4 parts of pi. So you're going to go with pi over 2 as a starting point and travel pi each time to the good point. What's the vertical, or the center line for vertical shift of the graph? 2. And what is the vertical stretch or amplitude? 6, so it goes to a max of 8 and to a min of -4. And where is the starting point of negative sign? Pi over 2 is that the center line, the max, or the min? Center line. And a negative sine wave, does it go down from the middle or up? Down. So it should be at a min at 3 pi over 2, a middle at 5 pi over 2, max of 8 at 7 pi over 2, and then back to the middle of 2 at 9 pi over 2. We good? Okay. Let's go to, switch gears a little to problems that are also in the homework, a little different idea. We'll practice factoring here. You're going to need this when we flip this over. So sine cubed. Give me one way to break it up or write it as a multiplication problem. Sine makes sense. Let's call it sine times sine squared. The reason you would want sine squared is because there are lots of identities for sine squared. You could keep going sine as well. But let's just stop there, shall we?
Yep.
All right, this is not equation solving, by the way, it's just saying factor. What about 2? What could you do there? No. Okay, so it seems like students do better with a problem like this. What would you do there? Okay, you'd say x squared minus y squared and x squared plus y squared, yeah? All right, so use that as a guide here. Cosecant squared alpha minus cotangent squared alpha times. All right, one of those is an identity. So let's go a little further. Which one of those is a Pythagorean identity? Do you have your Pythagorean identities memorized?
No, are they gonna be on the test? But I'm gonna make
I don't know. What are these on? Aren't they on the test?
no.
Or is that set 80? You only need to, if you just know sine squared plus cosine squared is 1, you can get the others by dividing by sine and cosine. 80 is these. Darn it. It's
Yes!
just missed the test cutoff.
I have never successfully.
Why don't it's just memorizing. That's like Devlin's strong suit, just mindless memorizing. Okay, so what, if you could memorize 80 zillion physics equations, you can memorize 3 identities. What is cosine? Is it cosine squared? So let's actually do this here. I'm not good memorizer either here. That I can remember. Nobody forgets that. How could you get the cotangent identity from this? Divide by sine squared. So if you divide by sine squared, and I'm just going to use no shorthand, this would be 1 plus cotangent squared equals cosecant squared. Just like that, you could get the others if you just memorize the 1. So if I move the cotangent squared over, what is this one equal to?
1.
It's 1 times cosecant squared plus I think I wrote that wrong. That should be cotangent squared. Alpha. And their alpha is not big. You with me? Okay. Tangent squared minus 1. What's that equal to? Tangent squared. Is that secant squared or is that not quite secant squared? Okay, so let's factor it some other way. What's another way to factor?
Tangent theta plus 1.
Plus 1 and
Tangent theta minus 1.
there you go. All right, we'll call that good. How about this fourth one? It's a trinomial. Think 1 minus 2x squared plus x to the 4th. Or x to the 4th minus 2x squared plus 1. Oh, is that what they wanted? I don't think that's what we wanted. I think that's meant to be squared. Change that to squared. I think that's what we want. Okay? So, what would you do? Here, what is this? How's this factor?
1 times 2.
Come on, people.
I don't know.
What are the factors of x to the
1
4th?
times sine squared. X squared.
And x squared. What are the factors of 1?
1.
1 and 1. And what do the signs have to be to add a negative 2?
Negative 2.
Okay? So that's x squared minus 1 all squared. It's a squared pattern. So this is the same as sine squared minus, not minus 2, minus 1 all squared. Okay? 5. What's the first step in factoring? Take out a greatest common factor. In this case, the greatest common factor of cosecant is 1 minus secant squared. Is that a thing? Does that do anything more? That's not cotangent. It is tangent. Is it? I don't think it is.
We don't know.
Okay, so let's start here. Sine squared plus cosine squared is 1, right? We want to get tangent. What should we do? No. Cosine. Okay, so tangent squared plus 1 is secant squared. So what's, looking at that, what's 1 minus secant squared? Is it tangent?
It's cotangent.
Hey, no, you're thinking way in the wrong direction here, okay? So if I wanted 1 minus secant, would I subtract this away, yeah? And so that would be negative tangent times negative tangent squared, sorry. All right, last but not least, what is a cubed minus b cubed factoring? A minus b, a squared plus ab plus b squared. The signs are so same, opposite, positive. So here we go. This is beta minus cosine beta times sine squared beta plus sine beta cosine beta plus cosine squared beta. There is one more thing we can do with an identity. What is it?
You can make cosine squared.
Yeah, these guys together equal a 1. So we could call this sine beta minus cosine beta times 1 plus sine beta cosine beta. Yeah? All right, let's flip it over. Oh, stop. Okay, so some identities today will involve factoring. We just did all the practice you need to succeed. So we're showing these are true. Give me one thing I can do. Factor out a sign. Yes, factor out a sign. We're going to use factoring today. Okay? Give me something else I can do. 1 minus cosine squared is sine squared. And sine times sine squared is sine cubed. Boom. Okay, so factoring. All right. What about example 2? What can I do?
These make sense on us.
They make sense all the time.
Wait, what was your second step there?
From here to here,
Oh, that just
I use the identity sine squared plus cosine squared equals 1 rearrange. Okay? Example 2, what should I do to the numerator, the denominator, or the tangent? What should I do?
move it up.
Okay, let's factor. As I said, today the moral of the story is factoring. So maybe we should factor something. Okay, how does it factor? Secant squared theta minus tangent squared theta and all right, then boom, they divide away. Don't forget that plus tangent squared off to the side there. So now you have secant squared minus tangent plus tangent. See, when I factored, I was able to divide out a secant squared plus tangent squared, leaving me with secant squared minus tangent squared from the fraction. And that's all. Then, if I combine the negative tangent squared and the tangent squared, I just have secant squared. And doners. All right. How about this bad boy?
take out everything.
Feels like it's already got it factored. Maybe we should unfactor
Wait,
it?
doesn't that mean it's still like combined?
Well, side and there's literally nothing else got.
Let's, I don't know what to do, so let's just do something. Tell me something we can do.
Unfactored.
Unfactor or distribute. If I do that, I get cosecant x sine of x minus cosecant squared. What else can I do?
Change cosecant squared.
Change cosecant squared to what is it?
1 minus cosecant.
Sine squared plus cosine squared is 1. Cotangent is divided by sine. Squared sine squared. Seems like you guys should use your notes more. 1 plus cotangent squared equals cosecant squared. So what's cosecant squared? 1 plus cotangent squared, yeah? You follow? Okay, now what do we do?
I have no idea now.
Give me something you could do.
Change cosecant.
Change cosecant to 1 over sine. Okay, then they divide out 1 minus, you do have to show that step. 1 minus, distribute the 1, the negative rather, 1 minus 1 minus cotangent squared is negative cotangent squared. Right? We distributed the negative. The ones went away, we got a negative cotangent, all is well. All right, last but not least, example 4, what should we do?
Factor.
Factor, how's the numerator factor?
Sine.
That's an alpha. Sine alpha minus cosine alpha times
Squared.
sine squared alpha
Plus.
plus
How do you even do that?
just we're just talking now. Sine squared plus
Plus sine alpha cosine.
okay plus
Plus
cosine alpha squared over sine alpha minus cosine alpha.
Top and the bottom. Oh, it cancels.
We do divide out, so now we have sine squared
And they get 1.
alpha plus sine
And they
alpha.
1.
What's 1?
You can't
Sine
change it
squared.
Can you just go straight to that step?
No, you cannot. Sine squared plus cosine squared is
Why?
1.
Why can't you just go straight there?
Too much at once.
But, you can literally.
All right.
Calm down.
Do you get it? Apparently no earn your problem sets today. I guess I'll just give you your problem set without earning it. Seems wrong, but fine.
Oh, I have a major headache.
When we first started this, I tried to do every single one, but every time I start, I get confused, and then it just doesn't end up the right way.
Shall we try the identity off the homework while it's fresh in our mind? You remember which one it was? It's number try number 9.
Oh, yeah,
Oh, I remember that. What did these things? What was that song?
Number 9 is the new type. Well, these are X's, not alphas, or thetas, sorry. Try 9. should. Very small. Yeah, it's actually not. Make it sound like it's your height or something, like it's not under your control.
Yeah, there's just not.
Very small word.
I'm writing very petite.
I doubt it.
Well, I am.
Look at this.
I'm writing. Your voice is really good. Oh my god, David walked off.
Got it.
Pretty easy, right?
Not number 9. I get
Number 9 is not easy. Okay. All right. How about 10? Try 10. What can you do to 10? Factor out a cosine.
Do you have to factor?
It's by far the easiest way to
Oh
go.
my gosh, I didn't know this.
I just changed sine squared.
It's probably easier to factor first. Then you can do it in 2 steps. It's a lot less writing. What's 1 minus sine squared? Cosine squared.
Don't even.
And so, ooh. All right. 11's not like when we did in our notes. It's not hard, but we're going to try 11. It should, if you're good, be something you could do before it's too late. Secant squared minus 1 over cotangent theta. Prove that equals tangent cube theta. Secant squared minus 1 is tangent squared. Okay, that's a good start. What else? What about the cotangent? Cotangent in the denominator is the same as tangent in the numerator. And you're home free. Boom. All right, good enough. Have a great day. That's at least the new ones
Darn, I have a lot.
done.
I didn't get